Windows 10, in-place upgrades and continuous servicing. I gotta imagine everybody in here is on their way to Windows 10 by now. I assume. Is anybody fully Windows 10 yet? Two? No. So we all know Windows 7 end of life next year. We all know we have to get to Windows 10, and we probably all know what Windows as a service means, but we'll just recap it here for good measure, right? With Windows 10, we get 2 releases a year. They're currently called semi-annual release. Microsoft has changed the names of this process several times since Windows 10 was introduced, but I'm hopeful that they'll stick with semi-annual release at this point. So basically a spring and a fall release every year. Spring releases are always 18-month support cycle. So if you deploy 1903, for example, you're on an 18-month track to get off of 1903 before it's out of support. Fall support lifecycle, so the second release of the year, is now 30 months support lifecycle. Note that that is Enterprise Edition only. I actually didn't know that until recently, that if you're using Windows 10 Pro, your support lifecycle is always 18 months, period, no matter what release. So you only get the 30-month lifecycle support when you move to the Enterprise SKU.
Does that mean that they'll stop releasing patches, or is it just a empty threat that you're supporting?
I just know it's supported for 18 months is the equation. So I don't know if there's something built into the updates to say I'm not going to apply to you anymore because you're Pro. I don't know what the implications there are. I just know that is Microsoft's official statement. So, yep. So that's interesting. I did not know that. New features in addition to security, right? New features are being added with each new release as well. And then we have our various management capabilities for Windows as a service, right? We can do it traditionally via ConfigMan. Is everybody a ConfigMan shop? Are you guys a ConfigMan shop? No, okay. So you can continue to manage Windows 10 like you always have with Windows 7 or XP before it, or when everybody went to Windows 8, right? No. So traditional management with SCCM. But Windows 10 was really built from the ground up to be the transition operating system into a monitored management workload. So it has an MDM sub system in it that allows it to be managed very similar to a mobile device. So the goal is to get an operating system that can be managed from anywhere. They did some of that in Windows 8.1, but we all know nobody really got aggressive with 8.1 rollouts. But vastly improved in the Windows 10 experience. So in addition to traditional management, right, you can also do co-management. So you can use your Azure Active Directory presence with Intune and SCCM to manage the devices on-prem with SCCM. I go off the network, I can be managed via Intune. You can also do just pure cloud management, right? If you don't have SCCM infrastructure, you can manage Windows 10 fully with just Intune and Azure Active Directory. And then there's some light management capabilities. If you don't own Intune and you don't own ConfigMan, but you have Office 365, you can do some light management of your Windows 10 devices, things around like Exchange policies and things like that. It's not very robust, but you have some capability there. So some of the challenges that I've seen over the last several years with implementing Windows 10 into an environment for in-place upgrades and things like that, from legacy operating systems to 10, but also from older 10 builds to newer 10 builds. Security software. So if anybody has rolled out Windows 10 that had McAfee, Trend, Norton, if that's even a thing anymore, so I can tell you McAfee specifically, on 2 occasions we've had this where the application works fine on the version of Windows 10 that we're going to, but if it's installed on the existing operating system, it breaks the upgrade. So we had to use task sequences to get around that, to remove McAfee, do the upgrade, put McAfee back on. If you actually go to Microsoft's document site, one of their first suggestions in their in-place upgrade is they recommend removing security software before upgrading Windows. Seems counterintuitive, but unfortunately, whatever it is between the operating system and the OEM for these security software, they don't seem to work very well together today. Yes, sir.
Third-party encryption tools have the same
same with BitLocker, right? You want to make sure you disable those processes, which is my earlier point. I've seen encryption software that does not provide any sort of scripted interface, which basically breaks your ability to do any sort of in-place upgrade. So having the ability to interface with that via automation as part of your task sequence to disable those protections during the upgrade is key. Another big piece of this, which we actually see a lot of companies maybe don't even realize that they should be going to UEFI, right? So Windows 7 was a legacy BIOS configuration, and all operating systems before that. We are very familiar with what an old BIOS looks like. A few years ago, UEFI was introduced. I believe that came out when Windows 8 landed, to start giving us a more secure boot process, in addition to being the fundamental platform on which everything, most of the security features of Windows 10 rely on that device booting in a UEFI configuration. So you can still build a machine with a legacy BIOS with Windows 10, but you can't do things like, let's see, credential guard, secure boot, right? All of those good security features that are part of the Windows 10 processes are no good to you in a legacy configuration, right? Can't enable them. So getting from a 7 to 10 and converting from a legacy BIOS to a UEFI configuration is key to really getting a more secure infrastructure as you move forward in your Windows 10 project. App compatibility, that's always something that's going to be there. I believe Microsoft has done a very good job, honestly, of not breaking most applications as you move from a Windows 7 to a Windows 10. Certainly not a blanket statement. There are pieces of software out there that are just not going to run properly on Windows 10. You might need to upgrade. Security software is one of them. I've seen a couple of cases where McAfee wouldn't even run on that version of Windows 10 until the next update came out. So they were working feverishly to get a new version of the AV product out to work with the next build of Windows 10. So app compatibility testing is can't be undersold of how important that is, right? We don't want to upgrade our machines and then create our users from being productive. That's probably a resume generating event. We don't want to do that, so app testing is always key. And then drivers are always a challenge too. So if I'm moving from a legacy operating system to Windows 10, odds are the drivers that drove my Windows 7 box are not going to properly drive my Windows 10, right? So I have to be able to apply a new driver set as part of that upgrade process as well. So the impact for us, right, is testing. Lots and lots of testing, right? So we're going to have to do this on a reoccurring basis, right? At the very minimum, if we're doing fall release support, and that's our standard, every 30 months we have to have already been on a new build. So you're talking every 12 to 18 months, right? You're going to be going through an upgrade process. Making sure that you don't break any applications, making sure that your hardware is going to support it, validating driver sets in the new builds, because you may be able to do half your models may upgrade just fine to the next version of Windows 10 with the drivers that are in place. The other half may prevent the upgrade from happening because the driver sets need to be upgraded as part of that. So lots and lots of testing that goes into validating when I'm going to actually start deploying that I'm going to do it in a manner of which is going to make me successful, right? So we talked about it's a continuous deployment process. So the years of, we ran Windows 7 for what, 12, 14 years, I think was about the support lifecycle for that, which was great because that means we really only had one big operating system upgrade project, right? And that was probably 10, 12 years ago. And now it's just maintaining and deploying patches and all of that. Well, obviously with Windows 10, those days are gone, right? So we're going to be doing an OS upgrade project every 12 to 18 months. Now granted, it's much, much less archaic than it used to be in the Windows XP and 7 days to try to do in-place upgrades or do a big OSD project in general. Another thing is every time we go to a new build of Windows 10, right, we've got to tweak our in-place upgrade. So prime example is 1809 introduced a nice Edge icon on the desktop, which almost without fail, everybody that we deployed this to in our customer base was like, we don't want that shortcut on the desktop. We don't use Edge, but that was a feature that Microsoft built in, right? So those kind of things that we have to constantly be looking at to see and tweaking our in-place upgrade task sequences to make sure that we're providing the best user experience. And then when we go to a new build, we also have to create a new computer task sequence for that version of that operating system. We don't want to continue to deploy a download our operating system in our Pixie wipe and load process, and then just have to turn around and upgrade that when we're in the middle of an upgrade, right? So we have to do those things together to make sure that as we have approved that operating system works with everything, that becomes your standard for all new builds. And then of course we talked a little bit about it, driver updates. So some OEMs, if you've actually gone out and looked at their website, are now releasing driver packages that are specific to build versions of Windows 10. So there's, I'm not a developer, clearly. I don't know what the underlying pieces are that require driver updates to go from one version of 10 to the next. But it's a very common scenario that we have to address in our in-place upgrade process or our continuous servicing process. So some optimization ways to help this is upgrade readiness. Is anybody in here using upgrade readiness? No. Does anybody not know what upgrade readiness is? Okay. This is a very, very, very powerful tool that is free. It's a free cloud service, right? If you have an Azure subscription, you can spin up a free version of OMS, but if you own OMS, this is a component of OMS. You can use it in the paid version or the free version, doesn't matter. And then what you do is effectively you, before we go to the nets, right? The telemetry engine that's built into Windows 10, or even Windows 7 for that matter, if you're still going from 7 to 10, you can send that telemetry data to your instance of OMS and to the upgrade readiness. And then using the vast database that Microsoft has from millions of clients, probably billions at this point, across the globe, they have a giant subset of data that tracks known application problems, known driver problems, all this different hardware, and they compare your data against what their database tells them, right? You have these applications, you have these models, you have these driver sets. We know this does not work and you're going to have to address it before you upgrade. This application is not going to be compatible with the next version of Windows. It's certainly not going to give you everything because there's going to be things that are unique to your environment that they've never seen before. So some things will show up as unknown, but it really gives you a deep dive look into your operating system platform to see what things are going to potentially break before I upgrade. So very, very powerful. I highly recommend everybody implement this as part of their Windows 10, whether you're already on Windows 10 or you're still moving to Windows 10. This is going to help you. When you go to move to the next version of Windows, you go into the service and you say, now my new target version of operating system is 1909 or whatever the next release is. And it's going to compare all of that data with everything it knows about 1909 now and tell you where your potential pitfalls are going to be. So very, very useful tool that's free for everyone. There is some light integration with SCCM, but really the portal is going to give you the deep dive into the data. But you'll get some dashboardy type information in your SCCM console if you want to integrate that as well. So very, very, very useful tool that is free, so I feel like there's no reason not to use it, right? If you can convince whoever's managing your Azure, if that's not you, to help you configure this, it's a no-cost solution for everybody. The other piece is dynamic deployments. For the people that are moving to Windows 10, are you guys using task sequences today for in-place upgrades? I know a lot of people are doing like wipe and loads or new computer replacements, but anybody doing in-place upgrades with task sequences today? Okay, so task sequences are definitely still king. We have the ability in SCCM, if we so wanted, to set up deployment rings and try to deploy Windows 10 updates just like a software update. Right? Sounds very cool on the surface, right? I can just set my deployment rings, and then every time a new release is available, I can just let it go out and as part of my software update process, upgrade my machines. But remember all the pitfalls that we had talked about and the challenges of getting to Windows 10. What I can't do in that scenario is I can't take action on security software that may break my ability to upgrade. I cannot convert from legacy BIOS to UEFI as part of that process because I have no way to do that. So there's a lot of things that you're missing if you try to use the deployment rings, where task sequences give you full pre and post deployment processes, right? I can do pre-caching, so I can cache all of the content. So one of the biggest challenges that we ran into in our Windows 10 deployments was people who are on Wi-Fi or people who are on very slow connections. Right? That's very challenging in a traditional in-place upgrade task sequence to get that process to work on a poor connection. Or if, let's say, in a scenario where I have a product that I have to uninstall, like an AV, because it's blocking my upgrade. Generally, an uninstall of an AV requires a reboot. So I have to put a reboot into my task sequence. Well, if I do that now in just a standalone task sequence, it's going to go through, remove the software, it's going to reboot the computer, and now I'm sitting at a login prompt. So my user is like, oh, I guess it's done. They log back in, and your task sequence is actually still running in the background. It just had to reboot the machine. So it's a very poor user experience from that scenario, so we'll talk a little bit about how we overcome that. But having the ability to take everything that's required for my in-place upgrade, so if you can see what we're looking at here, these are just snapshots of the 2 different task sequences that we would use in our in-place upgrade. So the one in the back is our pre-caching. So we use that to pre-cache the operating system. If there's a driver set specific to that machine, we use it to pre-cache that. And any applications or data that is referenced in the other task sequence, the one in the front, that's going to actually do the upgrade, is all pre-cached first via the first task sequence. The other pieces of that is we're running a compatibility upgrade process, right? So if you all are familiar with the in-place upgrades, there's a tick box on the upgrade Windows step to say, don't actually do the upgrade, just run through it and tell me if something's going to be incompatible. So we run that compatibility test as well. What we've seen is on average, on a decently connected device, that entire pre-caching process is like less than 15 minutes to go through, pre-cache everything, and to run a compatibility scan against that machine. We use hardware inventory extensions and registry keys, so we've extended the schema for the hardware inventory, and we write success and failures as part of our pre-caching process. Right, was I able to pre-cache my content? Yes, write a registry key that said it was successful. Was I able to pre-cache my operating system and all my packages? Right, was I, what was the exit code of my compatibility run? Right, if it's a not 0, if anybody's gone through that, for whatever reason Microsoft didn't think an exit code 0 would be useful. It's only the way everybody does it. So there's a very specific exit code that means I passed and it's not 0. So we can key off of that as well to see that the compatibility test run properly. And if it didn't, we write that again to the registry. Then we use collections within ConfigMan to pull that information back in hardware inventory to see, I push this out to 100 devices, I know that 20 of them failed that compatibility check, and I can look and see what 20 machines are and go figure out why that was. And again, we're capturing all of the logs along the way as part of this process into a network folder so that we can go look at all of the Windows 10 in-place upgrade log. We can look at the task sequence logs, right? Anything that's relevant to what's going to be needed to upgrade that machine, we're grabbing that information, putting it into a network share. So assuming we get through all of that, and all of our pre-caching and our compatibility ran successfully, that means we now have a collection of machines that we can target with our upgrade task sequence because they're going to run it. One of the other things that we can do, clearly we've talked on several occasions, is converting legacy BIOS to UEFI. Very, very important, right, for Windows 10 if you want to take advantage of any of the security features, which I would hope that you would. So getting legacy to UEFI, converting into your task sequence is key for that, to make sure that you're getting as secure as possible. And that's done through OEM tools, right? So you have to use the OEM BIOS interfacing tools. Lenovo, for example, is a VB script. That's how they interface with their BIOS, which kudos to them. Maybe that someday they'll update it to PowerShell, but at least it's all driven through WMI interaction. Dell has the CCTK, I think is what it's called, that allows you to interface with the BIOS. HP has their own utilities. Microsoft doesn't need those utilities because they all ship in UEFI configuration. I'm not even sure you can go legacy on a Surface or not. I don't think you can. Can't say I've ever tried. But so you have to use the vendor tools to make the changes, and then there's a utility built into Windows I think it was like the second or third release of Windows 10, that converts your partition types from master boot record to GPT, and the various changes in the partitioning. So they allow you to do that. So using those utilities in a task sequence, I can easily convert my devices from legacy to UEFI as part of my in-place upgrade. And again, we have pre and post upgrade actions that we can take because it's a task sequence, right? We can do things after the upgrade is complete. We can also key off on a rollback if it started the process and something stopped and it rolled that operating system back. In our task sequences, we can key off of that and we can take action. Like if I had to uninstall my AV and the upgrade fails and rolls back, I want to make sure that that antivirus gets back on that machine rather than just leaving it exposed. And then self-service. So we have been taking this approach with our clients, and we have found great adoption and good feedback from the IT as well as the end users, is putting the upgrade into your user's hands with a subset of IT restrictions around it, right? Like a deadline date. Using a tool, we use a tool by a company called OneVen. If anybody's not familiar, you can go Google that. It's basically a scheduling front end to a task sequence. So we can deploy our task sequence to our devices, right? Maybe put a deadline date 30 years in the future so it doesn't actually kick off by itself. And then put this OneVen tool in place and deploy that. And what that does is it gives the user a dialogue to say, you have to upgrade your operating system, right? You can put your own verbiage in there. And then I have the ability to schedule it for a time that's convenient for me. Or I can click install now if they so choose. And actually, surprisingly, a lot of people just go ahead and click install now. But they can schedule it, right? So if they're busy and they know they're going to be busy for the next week, we've given them 30 days, let's say, or 2 weeks, say you can upgrade yourself. At the end of 2 weeks, we're going to upgrade it for you, regardless, right? So it really has driven a lot of adoption and rapid adoption, right? Given that ability to the user, rather than trying to go through the arduous processes of, right, okay, we've got these 20 machines, we need to make sure we work with these users, they're going to leave them on tonight, we're going to try and force an upgrade on them while they're online. The user shuts the machine down, or they actually take it home and they don't do it, and so you can't actually upgrade. It can be very frustrating. So having a user-driven process here gives the users the capability of scheduling it themselves.
What was the name of that tool?
I don't know if it actually has a specific name, honestly, but the company is called OneVen. So if you just Google OneVen task sequence or something, you'll find it. It's a free tool. It's written by a guy out of Sweden. Has been actively developed. He's done a lot of enhancements since its release. So it's a really, really cool product. Another great thing about this tool is that it has an MSI that you can apply as part of this process that creates a service that does a fake Windows 10, your Windows is upgrading with a little wheel that spins when you're upgrading. So when I have to do things like uninstall AV and reboot the machine, instead of coming back to a login screen and making the user think, well, it might be done and I'm going to try to log back in, it throws a full screen, I'm still upgrading Windows dialog up after that reboot, right? So it's a much, much better user experience. The first time we deployed, or we tried to deploy without that, that was what we were seeing that very quickly prompted us to go, we need some sort of interface into this, because users were doing just that. They were rebooting the machines, logging back in, rebooting, all kinds of things to break that task sequence that was still running in the background. So it was a very poor experience until we implemented this tool. So with all of these things, right, the hero moment here is if I've gone through upgrade readiness and I've created all of these dynamic task sequences and I've obviously tested all this stuff and it works great, and I know I can target 90% of my organization now because they're on slow links or they only use Wi-Fi or things like that at home, I can still target them with this process. So if I pre-cache everything, I can run that completely offline. I can take that machine completely off the network. Now, what is normally maybe a 30 to 45 minute process is going to turn into a 4-hour process when it's offline, because if you don't know every single step in the task sequence, your client is trying to send that status back to the management point about success failures of everything that's happening. I mean, it can't do that. It does a retry, right? Every few seconds, it retries a few times before it finally moves on. So those retries per process in your task sequence do add up. So it's going to take much longer in an offline scenario because of that, but it's still going to work because you don't need network connectivity to get that upgrade completed at that point. So the goal here, right, is that when I start down my Windows 10 servicing path, I can do it with confidence because I've got the data. I know what's going to break. I know that I need to go fix that prior. Right? I'm using upgrade readiness to see what apps I may need to address prior to my rollout. Right? What drivers I need to upgrade, all of those sort of things. Along with dynamic and self-service driven task sequences has proven to be a very successful combo of getting Windows 10 implemented in your organizations. Any questions about that?
Have you seen the Windows Analytics yet? Is that going to replace some of these things, or?
I don't know. So like upgrade readiness itself has changed several times since they first implemented that, changed names. So I don't know if they'll end up rolling that into Windows Analytics at this point or not, but seems to make sense that you would try to just combine all of that into one platform for the various reasons of why you would use it. But I don't know for sure if that's on the roadmap or not. And you can configure telemetry data for your clients now in SCCM if you're on a certain version of current branch. So if you're keeping your infrastructure, your SCCM infrastructure updated, the telemetry settings can be configured in the console and applied to your devices. You don't necessarily have to use group policy, but you can use group policy to configure that as well if you'd like. All right, any other questions around our new jobs of constantly upgrading Windows? Everybody excited about that? Okay.